This is question number 4 of exercise 5.5 from the chapter Continuity and Differentiability. The question is differentiate with respect to x, x to the power of x minus 2 raised to the power of sine x. Okay, now to solve this question we assume that the given function is equal to y. And here you can see that we have x to the power of x, which is a function raised to the power of another function. And 2 raised to the power of sine x is a simple composite function of an exponential function and trigonometric function. Okay, but here x to the power of x can only be differentiated if we take log. Okay, because if we have to differentiate function raised to the power of function, the only method which is applicable is logarithmic differentiation. Okay, so whenever we have been given a value which is adding or subtracting like this with a function raised to the power of function, then the method is little different from directly applying the log. Okay, and what we have to do in this, we have to assume that one of the function is equal to u and other function is equal to v. So u is equal to x raised to the power of x and v is equal to 2 raised to the power of sine x, and y can be written as u minus v, or dy by dx would be equal to du upon dx minus dv upon dx. So what we are going to do now, we are going to calculate the value of du upon dx and dv upon dx separately and place the value here to get the required answer. Okay, so whenever function raised to the power of function is added or subtracted to any value, any sort of value is adding to it, then this is the method which is going to be used, and this is the concept which you have to remember. Okay, so we assume that u is equal to x to the power of x raised to the power of x. So taking log of both sides, log of u would be equal to log of x to the power of x, or log of u can be written as x log x. Differentiating both sides with respect to x, I'm going to get d by dx of log of u is equal to d by dx of x log x, and 1 upon u du upon dx, that is differentiation of log of u with respect to x, would be equal to first function into differentiation of second function plus second function into differentiation of first function, that is x into d upon dx of log x plus log x into d by dx of x, and differentiation of log x is 1 upon x, differentiation of x is 1. This x and x would cancel out in the next step, so I'm going to get du upon dx is equal to u into 1 plus log x, or du upon dx is equal to x to the power of x into 1 plus log x. Okay, further v is equal to 2 raised to the power of sine x, and dv upon dx is equal to d by dx of 2 raised to the power of sine x. So here we can differentiate it directly because it is simply a composite function of exponential function and trigonometric function. So d by dx of 2 raised to the power of sine x would be done as we differentiate a to the power of x, and differentiation of a to the power of x is equal to a to the power of x into log a base e. So this would be equal to 2 to the power of sine x into log 2 base e, and because here we are differentiating 2 to the power of sine x, not 2 to the power of x, so we are going to multiply it with d by dx of sine x, which is equal to cos x. So dv upon dx is equal to 2 raised to the power of sine x into log 2 base e into cos x. Okay, so all we have to do, we have to just now place the value of du upon dx and dv upon dx, which has been calculated, to get the required answer. So dy by dx is equal to x to the power of x into 1 plus log x minus 2 raised to the power of sine x into cos x into log 2, and it is understood that base is e. So this is my required answer.